Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, or the Anne Arundel Community College Networking 2 course. And today's packet tracer, or actually I should say today's lab tutorial and solution set is going to be on Lab 8.1.2.4, where we're going to take a look at configuring DHCP v4 on a Cisco router. Now, what's unique about this is that we're going to be doing this activity in Packet Tracer. However, remember, when you download the Word document, this is a lab that would typically be done in a classroom setting where you have the devices that they indicate you should be working with. And so in this case, it would be Cisco 1941 routers running iOS 15.2.4M3 with some 2960 switches, 2 to be exact. So we're going to have to build everything out here from scratch. So let's dive in to Packet Tracer. Again, right down here along the bottom, I've got a choice of some routers to pick from. I'm going 2911s. Right, I'm not leaving anything to chance here. So we're going to pull 3 2911s out. And let's see, it's going to look like this. And then there's like this ISP Internet Cloud thing going on over here. And we've got some distance between the routers. Now I'm going to enlarge this. Don't panic. I'm going to enlarge it as soon as I get everything out here. So now I need a 2960 switch. I actually need 2 2960 switches. So I'm going to drag those from down here. I clicked over on the switches tab, pulled 2 2960s out, and now we need 2 generic PCs. We've got PC 0. And we're going to go, oops, sorry, didn't want to do that. We're going to do that PC there. So now that I've got all of the pieces to the puzzle on the chessboard, let's do Control I, and that is what allows me to make things larger here. So this is where I'm going to kind of group things a little bit closer together, and it'll look a little bit nicer here once we get this all kind of laid out. And PC1 will go with switch 1, and we're going to be changing the names of these here shortly. So now we're back to Control I. There we go, and that's, whoops, that's pretty large right there, and so we'll stick with that. Now I'm going to get the connections up. I click on the little lightning bolt here, and we're going to go with the straight through cable from PC, oops, didn't want that, sorry, from PC 0's Fast Ethernet, and this is going to go into Fast Ethernet 06 on our switch. And then we're going to do the same thing, straight through from Fast Ethernet 0 to 018. Okay, and then we are a straight through from FA05 up to the router interface, gig 01. And then we're going to do from the switch here, we're going to go Fast Ethernet 011, and I'm not sure why they changed it to different interfaces on the switches to gig 00. Now we need our serial connections, and you can see we've got a choice here when I mouse over this. Actually, come on, pop up here for me. That's not going to do it. When I mouse over, it should tell you if it's the DTE or the DCE. Now, it's kind of irrelevant with the routers that we've got, but we'll go ahead and we'll do, I forgot. So because I chose the 2911s, right, we're going to have to go into the router, and I'm going to turn the router off. And it's nice, tiny little button right there where I would click to turn the router off, because we're going to go ahead, I'm going to make this a little bit larger here, and on all 3 routers, I'm going to grab an HWIC 2T, and we're going to put it in the rightmost slot, and then I'm going to power the router back on. And I'm going to get the CLI to confirm it's coming up. So we're good there. Let's get router 2 configured. So we turn it off. We drag an HWIC 2T card over here, turn the router on, and I'll close the window down. We're going to pull the router up here. HWIC, oops, sorry, I got to turn it off. HWIC 2T, and then turn the router back on. So now, when I go to the connections, and if I mouse over, it's still not cooperating here. It should say right along the bottom, it would say DTE or DCE. So we'll go with whatever connection it is we've got there. So this is going to be 000 up to serial 000, and then the final connection for this activity is going to be serial 001 to serial 001. All right, so now I'm going to move things around just a little bit here. We're going to go to the top. Whoops, we're going to go up to the top here, and we're going to do this. Kind of make it look just a little neater. There we go. All right. We'll get the PC set up here again. Just doing a little house cleaning, and then we're going to be off and running. So there we go. Okay, so that is the environment with which we are working. So let me scroll down here in the Word document and see in part 1. Okay, they want us to go ahead and configure some basic device settings. Cable the network, initialize and reload the routers, and on each router we're going to configure some basic settings. Now, let's see here, they've got the line con set up. There's some notes here. On router 2, do not configure router 2 with a domain name or a lease, as these commands are not supported in Packet Tracer. Okay, so no domain name and no lease. And so the common settings that they want are the following. And we'll start over here, and this is actually, let me make sure I've got this straight. Let's rename these right now. Let's go to the config, and this is going to be ISP, and then the host name is going to be ISP. And so we'll save that. Router 2 is going to be, this will make it a lot easier here. This will just be R2 and R2. So we were good to go there. And router 0 is actually router 1. And switch 0 is actually switch 1 and switch 1. And switch 1 is actually switch 2. Switch 2, switch 2. Whoops, switch 2. There we go. All right, so the configuration that they're looking for is the base config on each of the routers, and I'm just going to rip through this here. So we're already in global config, and they provide this, so you could literally cut and paste these things if you wanted to. So no IP domain dash lookup. They want service password encryption. Service password encryption. They want enable secret to be set to class. They want banner MOTD to be unauthorized access, and that's all we need to get in there. We don't need much more than that. They want line con 0, the console line, to have a password of Cisco. And they want us to have it to be logging in, logging synchronous, so that it doesn't mess up our output. Logging synchronous, sorry, I can't spell synchronous. And then line VTY 0 through 15. We're going to go ahead and say password is Cisco and login. So they've got to put the password in when they go to log in. So let's go ahead and say write mem here. We're going to pull router 2 up, and we're going to do the exact same tasks, right? All right, so we're in global config. I'm going to go ahead and say no IP domain lookup, service password encryption, enable secret is going to be Cisco. It's going to be class. It's going to be class, and then banner MOTD, no access. All right, and then line con 0 is logging synchronous, and then we're going to say password is Cisco and login, so that they are prompted with the password before they can get logged in. Line VTY 0 through 15, and password Cisco and login. And so that's going to take care of this router. We're going to give it a write mem here to keep all of our settings. And over to router 1. And I'm actually not going to do this on the switches. We'll go ahead and leave the switches the way they are. So we're going to go, we're in global config, and we're going to say no IP domain lookup. We're going to say service password encryption. We're going to say banner MOTD no access. Let's put something in there so it has something. Line con 0, logging synchronous, and then password, password Cisco, and then log in. Line VTY 0 through 15. Password is Cisco, and they're going to have to log in, and that takes care of our base settings. Okay, so configure the host name is shown. We did. The IPv4 address on the router is shown in the topology. All right, so let's go back to the topology here. So we're on router 1. So let's get into global config interface gigabit Ethernet 00. I'm going to say IP address, and it's supposed to be 192.168.0.1. It's a /24, right? So nice and easy. We're going to give it a no shut. That interface is going to come up. Interface gigabit Ethernet 01. IP address 192.168.1.1. It's a /24. Whoops, /24. Give it a no shut. Let spanning tree go crazy there. All right, so that interface is up, and then interface serial 000. Now again, if it says DCE, excuse me, or once the clock set, you don't need to do that, so don't worry about that. IP address 192.168.2.253 and 255, and we'll say no shut. All right, so that takes care of router 1. Let's do an end and a write mem just in case. On to router 2, we get into global config interface serial 000, IP address 192.168.2.254. Is that right? Yeah, 254, and we've got a /30. Say no shut. That link is going to come up. Serial 001 is going to be IP address 192.168. Whoops, sorry about that. Made an assumption there. 209.165.200.226, and it's a /27, so 255.255.224, and then a no shut to bring that interface up. So that takes care of router 2. So we're going to do a write mem here, and then let's come up here to ISP. Get into global config on the ISP router, into interface serial 001, and we're going to say hold on a second. Oh yeah, okay, I'm sorry. We're going to say IP address is 209.165.200.225, and that is a 24 as well, 255.224. All right, and no shut. And so then that brings that interface up, and so we'll do a write mem there. So that is the IP addressing, according to the scheme that we are working with here. All right, so we've taken care of all the basic addressing, and now we're on to some RIP. So on router 1, they want us to configure RIP, and they actually give us the configuration. So pretty straightforward. We say router RIP. We want to be running RIP version 2, right? I need a network statement in here for the 192.168.0.0, the 192.168.1.0, and most importantly, the 192.168.2.252. That is the interface on which I'm now going to be sending RIP broadcast, or I'm sorry, RIP multicast messages that are going to go out. Now, what they don't have us do, and I should make sure we get no auto summary in there. What would we do? What should we do here in addition to what we just did in the RIP config? What do you think? Absolutely, right? Do I have any RIP speaking routers down here off of switch 1? No. Do I have any RIP speaking routers down here off of switch 2? No. So what are we going to say? We're going to say passive interface gigabit Ethernet 00, passive interface gigabit Ethernet 01. Because again, I'm still going to be advertising those networks to router 2. It's just that I am not sending RIP advertisements down to PC0 and PC1. And those probably aren't even the PC names. Hold on. It should be PCA and PCB. So we'll sort that out here real quick. So let me pull this up and we'll go to config, and this is actually PCA, and this is actually PCB. PCB. And it may seem like administrivia here, but again, I just want to make sure that what you're looking at looks like what we're actually doing. So back to router 1. Passive, both of those interfaces do show IP interface brief, because again, I don't need to send RIP updates out those interfaces. It doesn't buy me anything, okay? So we've got it taken care of here on router 1, and let me make sure that everything looks good. And if I was to say, if I was to do a quick write mem, and actually let's say write mem, and I was to say debug IP rip, what would we see here shortly once we have a RIP advertisement get sent out? Well, we'll come back and give it some time. RIP is very slow, which is why RIP is not used a lot, if at all, in enterprise networks. So now we're on router 2. We're going to do the RIP configuration as well, right? So we're going to say router RIP. We're going to say version 2, and there's a typo in the lab right next to this. It says router 1, but it should be router 2, right? So version 2, we need a single network statement, 192.168.2.252, because this is where we're going to establish the RIP adjacency with router 1. I'm going to go ahead and I'm going to say default information originate, right? Because we're going to be originating a default route down to router 1. I'm also going to say no auto summary. And for passive interface, and that one activity, right? They had us passive that interface between us and the ISP. But again, there's no reason to passive that interface. We're not running RIP on that interface, so we're not going to do it. And the lab doesn't have us do it. So we're good to go there. All right, we need a default route here. So we're going to say quad zeros, and we're getting close to the DHCP, trust me, 209.165, 200.225. All right, so what I'm going to do now is I'm going to come down to router 1. You can see that we are receiving the RIP updates, right? We are receiving the RIP updates. So if I was to say show IP route RIP, that's all I need, right? All I need is that default route telling me, hey, come up here to router 2, and then router 2 will take it from there. So verify network connectivity between the routers, and we clearly have network connectivity because we're getting that default route. Okay, verify the host PCs are configured for DHCP, so desktop and DHCP. And desktop here on PCB and DHCP. All right, so now we are into DHCP. So to automatically assign address information on the network, we're going to need to configure R2 as our DHCP server. Now, here's where it gets interesting, because up until this point, right, we've kind of been dealing where everything is taking place with a single router. Well, now the broadcast domain, right, is not going to be outside this router for PCA and PCB, right? In fact, we're going to have to set up a relay agent is what it's referred to. All right, so on R2, we're going to configure the addressing pools. It's going to be on for each of the R1 LANs, but we're going to have to set up a relay agent because remember, that discover request is a broadcast, and it's bound to the broadcast domain. By default, routers do not by default forward broadcasts, right? Because remember, they break up broadcast domains. So in the scenario that we have here right now, right, looking at router 1, you've got, and I'll do this, you've got a broadcast domain here, a broadcast domain over here, and a broadcast domain up here. So router 1 is looking at 3 different broadcast domains. So a broadcast that shows up from PCA is not going to get sent over here to PCB or to PCB's LAN, and it's not going to get broadcast up here by default. So we've got to take steps to make that happen. So let's go back into our control section here. It says exclude the first 9. Okay, so let's get on to router 2 here, and I'm going to do these, kind of do it as we read through the activity. So we're in global config mode. So use the pool name R1 gig 0 for the gig 00 LAN and R1 gig 1 for the gig 1 LAN. Now, you're also going to configure the addresses to be excluded from the addressable best practice dictates the address to be configured. Yeah, okay, so interesting here. So best practice dictates the excluded addresses get done first to make sure they don't get leased out by accident. And this is what we were talking about in one of the previous activities when I said, yeah, I always do it first. That way I don't have to back out of the DHCP config. But the true technical reason is what I just said. It's so that they're not accidentally given out. So we want to exclude the first 9 addresses, so IP DHCP, excluded address, and the low address in the gig 00 LAN, and hold on, I've already forgotten this. Show IP interface brief. Gig 00.0, okay, good, that'll work. So we're going to say 192.168.0.1 to 192.168.0.9. All of the addresses should be available. Make sure that each DHCP address pool includes a default gateway, the domain name ccna-lab.com, and the DNS server, and a lease time of 2 days. Now the note said Packet Tracer is not going to have the domain name or the lease options, right? So that's okay. So we'll skip those. So there's my IP DHCP excluded command, and I'm going to rerun this command for the .1 network, which is the gig 01, and let me make sure they want 9 from both in each R1 LAN. All right, so that excludes the first 9 IPs in each of the R1 LANs. Now let's knock the pool config out. IP DHCP pool, and the first pool is going to be R1 gig 0. Right now, you can see we've got the default router, the DNS server, and the network statement that we can put in here. And remember, there's only 2 of these that are mandatory for DHCP to function. And the first is going to be the network statement. So the network is 192.168.0.0 and then 255.255.255.0. And that's hanging off the gig 0 setup there. And then the second thing that's required is the default gateway. So let's go ahead and say default router, and that is going to be the 192.168.0.1. It's that address, right? It's the gig 00 LAN address. And let me say you all to turn debugging off, show IP interface brief. And you can see it's that gig 00 interface. That is my default router, or going to be the default router when the DHCP address is given out. Now again, I can't do the DNS, actually not the DNS server, I can't do the domain name, and I can't do the lease, and so we're just going to go ahead and leave those off. The DNS server, however, I can get configured, and let's say DNS server is going to be 209.165.200.225. All right, so let's exit out. We're going to say IP DHCP pool, and this is going to be R1 gig 1, and same commands basically, right? So the DNS server is going to be the same. The default router is going to be almost the same, right? We need to update it for the interface that this LAN is attached to, and then my network statement is going to be pretty darn close to what we just had. So there we go. So that takes care of those 2 there. All right, so they want us to take a look at PCA and PCB. We know we need the relay agent. So what are we getting? We're getting an APIPA or an IPv4 link local address, right? So when I do DHCP, it's not going to work. It's going to bomb out because right now PCA is saying, here's the I'm trying to discover, right? That broadcast discovery, the DORA, discover, offer, request, accept. The discover's going out, right? And it's getting to router 1, and router 1 says, that's a broadcast packet. It stays in this VLAN, in this subnet, in this broadcast domain is where it's bound. It's limited to being inside of that hermetically sealed bubble that we call a subnet right now. So we're going to have to change this by configuring router 1 as a DHCP relay agent. Now, the command is not, you don't say relay agent. We're going to give it a helper address is how we do this. So we'll come into router 1 and we do it specifically on the interface where that broadcast discover packet is going to be showing up. So let's get into, let's get into global config, interface gigabit Ethernet 00, and I'm going to say IP helper address. Now, what address do I give it? Yeah, I give it the address of the DHCP server, which is router 2. So 192.168.2.254. And I do the same thing on, I do the same thing on gigabit Ethernet 01. Whoops, IP helper address 254. So again, the helper address goes on the interface where the broadcast packet's going to arrive. That DHCP discover packet shows up here. And then the router says, hey, I've got a DHCP broadcast packet coming up here, and I have a helper address configured. So let me help this guy out and go ahead and forward this on to the device, right? This IP where the DHCP server resides. So now we come back to PCA. We come into and actually look at that. That was pretty quick, right? So bang, we get the 192.168.1.10. I'll come over to PCB. 192.168.0.10. And did I configure those backwards? You see what's happening here, right? B has what A's address should be, and A has, and if I did, it's not a big deal, but let's take a look. Let's say do show run. Did I get this backwards? And no, so gig 00. Let me make sure I connected to the right interface here. Let's say interface gig 00. Oh, so I've got the interfaces backwards. So do not doubt me here on this one, right? We can fix this. This is not going to be that difficult. And I love that this is the fortuitous failure, right? So now I get to explain to you how we can delete links from our topology and then come right back and get the job done right. So let me go back to the very, very top here, and I apologize. So it was supposed to be fast Ethernet 05, and this was supposed to be, and you know what I think I just did? I think I had the interfaces right. I think I've got the addressing backwards is what might be going on. Fast Ethernet 011 is supposed to be gig 00, but what I need to check here, and it's actually probably gone at this point. Okay, so the IP addressing is still on there. And gig 00 is supposed to be 0.1. Okay, so the whole time I thought I was wrong, and I was actually right. I was just looking at it, the left-hand side would be 0, 192.168.0, and this would be 192.168.1, and it's not supposed to be. So let's say no shut. All right, so we are actually correct, where PCB is going to get a 192.168.0 address. But again, we got to take a look at how to delete links. Okay, that is it for this activity. They wanted us to do an ipconfig-all here. So if I come back to the desktop, the command prompt, I could say ipconfig-all. And we see our information on PCA. We see the IP address, right? The default gateway, the DNS server information, and notice the DHCP server. So it's picking that up, right? Because we've got that helper address that's getting that broadcast over to router 2. So my apologies for the panic there on this being backwards. It was actually correct. I just thought it was 192.168.0 on the left and 192.168.1 on the right. All right, well, that is going to do it for Lab 8.1.2.4, where we configured DHCP on a Cisco router. In fact, we did the helper address on each of the interfaces for the broadcast domains that are going to require it, so that it could forward that Discover packet up to router 2. All right, guys, I hope you had a good opportunity to work with DHCP over the last week or so. Good luck on this activity, and I will talk with you soon.